Okay, we're in section 55 now. It's a short section. Again, you're expected to read the contents. You're expected to understand the examples that are presented in the contents, and I'll go through those in this video. And then you're going to work on the exercises, and hopefully you're going to see a relationship to the exercises and the contents and the examples that are covered. Right, my name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra that dates back to 1904. The PDF document is being made available to the PRISM Mathematics projects, the participants in that. I realize some students want access, or teachers too, want access to this document. It's not published yet, but it will be published at a later date. If you need to reach out to me, my name is Bannon. My email address is also Bannon. That's B as in boy, the @ symbol, NNON.US. Okay, so I'm going to just kind of scroll forward to the contents. And you look at the contents, and it's certainly factoring, right? More factoring. Factoring is a big process over here. I do want to point out that a lot of students looking at this, if they're not reading it, they might be horribly confused by what's being asked of them. All right, so my bottom line over here is to look at the problem. And if I were asked to do this, and certainly if I were just asked to do this and I weren't thinking about it or didn't read, I would probably give it a shot. But there's no way you're going to get this thing to factor using your finger numbers at this point. But there is a pattern to it. All right, so I'm going to point out, that there's a possible pattern. But again, people say, "Oh, this is a trick." Not really. Not if you're reading the section. You're starting to realize that there's a pattern to the problem. So I'm going to point this out, that, A4 plus, I'm seeing this middle term, and it shouldn't be 2, by the way. If I were looking at that and I was looking for perfect squares, I would say 25B4. I'm saying the middle term should probably be, let's see, I'm going to have a perfect square, it would be 10. A squared, B squared. But this is not equal to that. But anyway, this would be a perfect square now. All right, but what do I get next? I put this down. What is it going to be? Minus, well, I got to get a 2, right? So it's minus 8, right? A squared, B squared. Now let me write this down for you. And I'm going to say this is a perfect square. Again, I'm looking for a perfect square. That would be A squared plus 5B squared squared minus, I want to write this as a perfect square. Well, you know what? The AB is pretty easy. But then I'm looking at the square root of 8 now. That's not so good, but I can write that down. And now I can actually factor this. What would it factor to? Let's write this down. It would be A squared plus 5B squared plus the root of 8AB times A squared plus 5B squared minus the root of 8AB. I'm going to clean this up a tiny little bit. And what I mean by that, I'm just going to probably put it in order where descending powers of A. And I'll write the first one down. It's going to be A squared plus, well, the root of 8 is actually 2 root 2's, AB, and then I get plus 5B squared. We'll check with the key later. Next one, I'm going to descending powers of A's. It's going to be A squared. And again, the root of 8 is minus 2 root 2. I get AB, and then plus 5B squared. Put a box in this indicating I'm done with it. And I want to look at the key. And the key, let's read it. And I'm seeing the A squared minus 2AB root 2. I do see that. 5B squared. I'm seeing the A squared, 2AB root 2. Yeah, I see that, 5B squared. But someone says, they're different, the factors in different order. That really doesn't much matter. I'm not sure why I did that in the answer key. But anyway, I like my answer I've given. Okay, so this is kind of lending itself to doing the next problem. And I'd like to make it a perfect square. So let's take a look at it. And I'm going to write this down. So it's going to write x4. All right, I do see the 1. But I'm missing the middle term, right? So I'm saying it would be x squared plus 1 squared. So what would you get in the middle? You'd get 2x squared then. But what do I have to do? I have to take away 2x squared. All right, let's write this down. This is going to be, let's see, x squared plus 1. Again, I'm looking for a perfect square, so it's so easy to factor. Minus root 2x quantity squared. Well, I'm ready to factor that now. What's that going to be? X squared plus 1 minus root 2x, and then x squared plus 1 plus root 2x. Again, the difference of perfect squares. I'm going to write this in descending powers. So x squared minus root 2x plus 1, and then you get x squared plus root 2x plus 1. All right? So I'm going to say, looking at the key, I'm seeing that in both cases. All right? I'm seeing both of them. That's good news. All right? So you continue forward. Oh, by the way, I should mention that some people were saying, could you go on from this? Well, these are squares. So each of these things are squares, and these are squares. And you could play the same trick again, but there'd be complex numbers, all right? And that's good, because you could actually do that, all right? But anyway, I want to point out, you're looking at exercises now. You've done the first two examples. Let me get my highlighter out. What are you doing with exercises? You're going to exercise, all right? So what do? I go through a bunch of work. I really do. I go through a bunch of work over here. So, you do the problems, and I want to point out, I do write the answers down. Now, someone says, you have two different answers, all right? So what I do is I try to give you options. And I just want to briefly go through that with you. And some of the options are, just looking at it, you might see it differently. And that's why I prepare it differently. But I want to point out, each one of these cases would sum together to that original expression, which is x4 minus 7x squared. But I see two different ways of doing it. So someone says remarkable. It really is remarkable. All right, you want to take a look at that and pay careful attention to that. But here's the deal. If you're doing the problem set and you're matching this one, good for you. If you're matching this one, good for you. All right? Now, could these be factored further? Well, they're quadratics. Yeah, you could factor it further. You could complete the square root if you want. All right, let's go through this and make sure you understand what we're talking about here. This looks very similar to the original problem that we did. This one over here, again, you're looking for perfect squares if you can find them. And again, I want to point out that I write two different forms of it. So you can repeat this. If you're matching this one, good for you. If you're matching this one, good for you. Number 4, again, I'm looking for perfect squares again. And I did it. This one over here, I'm looking for perfect squares again. I saw two forms of it. Again, if you're matching this one, good for you. If you're matching this one, good for you. You don't have to do them both. All right, this one over here, again, perfect squares. Looking for a lot of perfect squares looking for, right? And then you get to this related Sage code. And you might be shocked, again, I want to see if you're shocked by these things, how quickly a machine can do this. All right, but Sage is a computer algebra system. CAS for short. It's open source software, so it's free. Download it if you like, or just use the indirect web-based application. And so type this stuff in. So what do you get? All right? Again, if you need to reach out to me, my email address is Bannon. I appreciate people that reach out to me and let me know there's errors. And why is that? It's to improve the document. That's the only point of it. Thank you for paying attention.